Hello team, this challenge is decimal to binary, where we're given a number and expected to convert it into its binary form. The binary form being ones and zeros. So in the case of 12, they actually give us the math. We divide repeatedly by 2 and record the remainder. Divide until the number itself is 0, at which point we finish. So 12 divided by 2 is 6, and then we take 6 divided by 2, 3 divided by 2, 1 divided by 2, and we record the remainder, which is 0, 0, 1, 1, and we flip it. So 1, 1, 0, 0, which is what the binary form of 12 is, right? That's easy. So hopefully we can sort that out right over here. And we are going to set up an output, okay? If I can spell it right, output equals a string. There's no clean way to represent decimal as a number. Or a binary as a number, it always becomes a string, which is just how it works. But we're going to represent it as a string, and then we are going to send that output as the return. So the output becomes the output, right? That hopefully makes sense. Right here, we're going to set up a while loop, and while decimal is greater than 0. So we are going to reassign decimal each time. We absolutely can reassign these arguments. They're kind of like lets in their own right, right? We will do that, and so long as it is greater than 0, we drop into this loop. Now, what do we do here? Well, we send output to be something else. We assign it to something else. In this case, I'm going to use a template literal, okay, which saves me on having to worry about maths doing the math thing. If I'm using the plus sign, the concatenation, there's a chance that it might actually try to do math, and I don't want that, okay? So the second one is the output, okay? Why can I not type that? My fingers just don't want to hit those buttons. But the first one is whatever the decimal is, modulo 2, okay? So we get the remainder of that, we put it on the front of whatever this string is, okay? Every single time, because we want it to be reversed, right? We don't want to have to reverse it later, so we just do that right now. And then, of course, the last part of this is setting decimal to be equal to decimal divided by 2, but this could give us a float, so right in front of it, we go math.floor, and that does it, right? That gets the job done. Exactly how they requested it with the maths, we can do that. A very manual process. Now, I would be remiss if I didn't show you how to do this in one line, right? Because JavaScript gives us a function to do this. I don't know about Python or other languages, but JavaScript definitely does. So we could take decimal and go to string. Now, normally this would have a radix or a base of 10. So it's going to try and convert that to whatever the decimal is wrapped in quotes. But if we want to change the base of this, we just tell it we want it to be base 2, which is binary, or base 16, which is hex code, right? Stuff like that. And we can absolutely do that and get it done. So manual, yes, absolutely know how to do it manually, because there are times where you might have to, right? Or you might need something else in here to happen based on that information. If all you're doing is returning that binary information, then yeah, the one-liner might be where you live. And I suspect that because this has existed for basically all of JavaScript's life, it would probably be pretty fast too, right? Instead of having to do this looping and math and stuff like that, it's probably pretty performant. But you let me know in the comments. Did you like the one-liner, or did you prefer the loop? Did you do it a different way? Do all that in my comments. And for now, this has been decimal to binary, and I will see you in the next one.